and the size of atom is a big question. And how exactly we use this crystallography for determining the arrangement of atoms in solids. So, like I have given the example that small atoms, we are having small atoms like helium with the size of 32 picometer, and cesium we took 225 pm, and the 1 pm is equal to 10 to the minus 15 centimeters. So we are dealing with very minute structures in chemistry. So here the structure of atoms are having. Here the plate structure we are having. And these are the arrangement exactly. How we are having the arrangement of atoms in a solid. So both the list of arrangement is shown up here. As will be knowing more. You will be knowing more about it. My fellow mates also have given a brief description about the structure, the positions of atoms in them. Now, what exactly was the earlier time? There was one instrument called a goniometer. It was an instrument which is over here, which was used for measuring the crystals only the crystals in our diagram. In the present situation, we are having various methods like one of our friends, not only one, said that we are having X-rays, the electrons, we are having, and various others. So now what exactly the crystallography depends upon? It depends upon the diffraction patterns. When beam of light is passed through the crystals, the beam when it's passed through the crystals, we are having atoms, they get the beam of X-rays, they get reflected by it, some of them get reflected, and some of them like refracted, some of them the energy get absorbed. These are the three things which happens exactly when the rays are falling on something. So we are basically dealing with the diffraction patterns which are formed, screen-like structures which we are having. These are some of the crystals. This is the screen. How exactly we'll be getting after doing all the stuff, passing the beam of light to the crystals, we'll be getting this kind of structures on the screens. This is really determining how exactly we can measure it. Next slide, please. So there are three types of, as I have given the information now, there are three types of diffractions according to the beam used. Like we are having X-ray diffraction, neutron diffraction, electron diffraction. We are using electron as a beam of radiation. We are using neutron as a beam of radiation. So we have this three type of, according to these types of diffraction, we are having three different types of crystallography. Basically, three different types of crystallography. Next slide, please. Now the theory, what exactly is there in the theory? Like we are focusing with the help of various instruments. Like we are having one of the instruments here, purposely like one more here, we are having, and forgetting the names of these instruments which we are using. But they are very much well designed to pass the beam of electrons. Like image of small object is made using lens to focus illuminating radiations as in which visible spectra in light microscopy. Like we don't require the visible light exactly. The wavelength of visible light is more as compared to that of a typical atomic bomb. That's why we don't use it. And and there are two types of zones created. Two types of zones created in earlier I have shown the screen which were having electrons. The zones are having electron density, and this is the whole case where exactly crystallography depends. Electron density determines the pattern which will be followed up on the screen. And if the electron density, that's why I have written that a higher electron density will be leading to the more reflection, and the lower will be leading to the lesser reflection. What are the steps which are followed in the crystallography? As I have said, collecting the X-ray diffraction patterns, solving the phase problems, calculating electron density map. This is one of the important, and it's not necessary that we use all the stuff like passing all these beams of light. We use a large amount of mathematics also in this. Next slide, please. This is a technique in the biological science, how exactly we use it. And we have created the proteins into the crystals. The crystals are determined with the help of the diffraction. This is the whole crystallography. And this type of patterns we get, and this calculation with the instruments like computers and various other, we get to the structure, how exactly it looks like. Next slide, please. Where exactly it is being used? These are very advanced technology sciences, college physics and molecular biology, pharmacy and chemistry also. Basically, these are some of the examples of it. Next slide please. So crystallography is not exactly dealing with all the stuff. It's also dealing with the astronomical units. Like if we say the Sophia, the flying plane in the NASA, which is used for determining the outer structures in the space. In turn, we are having various asteroids and all the stuff which are coming from the space. Can we examine how exactly they are? They have crystallography, and it is a very decent and can be used. And it is being used, and that's why to popularize it, we are using